All right, guys, let me, I'm gonna share this screen, share. All right, guys, settle down, please. Settle down, settle down. So here we have Z, that's binomial. And 9.45. Now, slow down, please, wonderful people. So A says a probability that the random variable Z is equal to 3. Okay, so how do we do this question? It's super simple. I think it's super simple. Let me set it up for you. So the probability of X has to be equal to, written NR, let me write X here, they like X. NX, P to the X, Q to the N minus X. So in this case, the X is 3. Now this here is N and this here is P. If P is 0.45, what is going to be Q? Now they don't write Q. They actually write this. They write 1 minus P to the N minus X, right? So what's 1 minus P gonna equal to? 0.55, right? So yeah, that would be Q. So let's just say Q is 1 minus P, just to remind ourselves. So Q is 1 minus 0.45. They don't use that symbology. It's going to be 0.55. So now all you do is substitute. You write probability of 3 must equal N is 9, X is 3, 0.45 to the third, and then you have 0.55 to the 9 minus 3, which is 6. Is everybody?
Is it P3 equals or is it P3 no?
Say again?
Like do the either. I'm slow.
No, you're not. You're not slow. Just a little bit. But yeah, guys, fast if you want to. Or just do small meals. You can do 3 small meals a day or 4 small meals a day. That's the only reason to bulk. It's easy. It's pleasurable.
So
people struggle with a happy life. People struggle with both.
Oh, I don't have that issue. Guys, see if you can do right now, and I'll pause the thing. See now that I did that one, if you could do B. Now, no, I mean you can solve it. Of course you want to solve. No, yeah, it doesn't matter. It's just I'm not solving it because I'm like, there, you can solve it. But let's say you wanted to solve it.
okay.
So you come to
P3.
so you're gonna have to use your calculator for this, right?
I'm just smart to do it by hand. Okay. P3 on.
All right, so first thing you do is NCR. So 9CR. This part here means 9C3.
Yeah, and then you multiply that times 0.45 to the what is it, third?
Yes. So you got 84. It's okay. Don't even stress over it. Just multiply it all through, and then you're gonna end up with the final number should be a decent number. That makes sense, and you should be able to check it in the back of the book.
How do you solve this, Mr. on the calculator?
Okay, so you go here, you press 9, and second 8, remember, and then 3, and it's 84.
When do you round it?
Okay, so what decimal did you get?
0.0276806.
0.02 what?
768.
So 0.03 is fine,
Okay.
or 0.028 is fine as well. Yes. All right, so if it's the 4th decimal, then you're gonna go. What's after the 6? So 0.277, because there's an 8 after here, and that's it.
Okay.
All right, so now you should be able to do the next one. The next one is just you do 4 and you also do 5 and add them together. So the next one is just gonna be, let me last one and move it a little bit to the right.
The final answer is another book.
So the next one is just gonna be basically gonna be probability probability of z equals to 4 plus the probability of z equals to 5. Shh, guys, settle down. You're talking too much. I know you don't want to pass the test. It's not interested, but come on. 0.45. It's okay. Hunger is fake.
I don't think so.
You have plenty of fat stores. You have plenty of calories. You can survive without eating for. I'm saying that you have sufficient calories to survive a few months without food. All right, guys, come on, pay attention. Look what I've written on the board. Now you do those two. I mean, that's it. I mean, I don't see what was the difficulty.
That, hello?
You need to do everything. Ooh, you know, come on.
What? What's the most answer?
Okay, so here. Okay, so that's how you got. Let me see. Natalia, you did something wrong with your calculator. Did you get it right?
I got 0.2120.
Oh, okay, so that's different than what you told me. Okay, do it again. Tell me again. For which one? For A?
Yeah.
For A, okay.
So 2, 1, what?
19.
1, 9, what?
2, 1, 1, 9.
2, 1, 1. What's after the 9?
That is it. So that's it. That's the answer.
Okay, so it was that answer. Okay.
That's the answer.
Okay.
I just put, so if I put like, okay, if I put 2, 1, 20, it's not probably not a big deal, right? So just.
Well, what was after the 9? All right, let me do it a calculator here.
I got 0.2120. Cause I didn't put the whole equation, I just put like 0.0277. Like I didn't put the whole entire equation. I probably rounded it here.
Okay, I'm gonna do it quickly because it's gonna take me like a few minutes to think this over, and it's better for me just to do it, just to make sure that it's right. All right, so when I do it with this calculator, I get 0.211881467. If we're running to, and this is obviously approximate as well, 0.2119 would be the answer. Fair enough?
Did you multiply?
Yeah. So the way you do it is you press menu, go down to probability, and then go to combinations. And then you put 5, whatever, 9, 3 or 9, 4. All right. Go ahead. Let me pause the recording because I'm wasting memory here. C, and then we move on. All right. So C says the following. C says, and by the way, this is page. I'll write it here. This is page 114. Page 114. Now, part C, that's not, you can check your answer after, but if you got Z is greater than 7, then here's how you do it. You basically have to take probability of 7 plus a probability of 8 plus a probability of 9. That's all you're doing. Because those are what Z are greater than or equal to 7. And then so essentially you have 9.7.45 to the 7.55 to the second plus 9.8.45 to the 8.55 to the first. And then you have 9.9. And you can get the numbers for that. Not interesting. Make sure you're ready for next test. And that's it.
Okay, hold on.
All right.
Always okay, so I'm kind of confused on the second.
Okay, so
Like, okay, I don't understand. Like the second exponent, is it always gonna start with 2 and then decrease, or is it gonna take 2, 1, 0?
well, it happens to be that way because what's 9 minus 7?
Oh, is that how that works?
Yeah, 9
Okay.
minus 8, 9 minus 9.
Okay,
You see it? It's part of the formula.
okay.
Okay? Okay?
And on the quiz, if I just leave it like that, would I get the same points for the house?
No, so yeah, you should, you
Like,
gotta get
my-
the decimals.
My calculator's kind of being moody right now, and
Your calculator is awesome.
it's probably the me then. I get.
Just practice. You should be fine. Okay, so now we're gonna go ahead and continue to miscellaneous 7, and I'm gonna do some problems which will use this for modeling purposes. So this is page, you won't see it now, but I'll put it up. It's page 119. And I wanna go ahead and do number 1. So I wish I could copy and paste, so I'll just write the probability of a novice archer hitting a target with any shot is 0.3. With any shot is 0.3. Given the archer shoots 6 arrows, thank you. Find the probability that the target is hit at least twice. Okay, so this is the first question, and it's a very interesting question because it's like a basic question that you should be able to answer. Now, there's too much giggling, too much talking. Okay. The probability of a novice archer hitting a target with any shot is 0.3. Given the archer shoots 6 arrows, find the probability the target is hit at least twice. So this is binomial. Now remember, the conditions that need to be met when something's binomial. That there's a fixed amount of trials. How many trials are we having here? 6. So definitely our trials here, and it's 6. Now there's two-part outcomes. You can either hit the target or not hit the target. So what's the probability of hitting the target? So that'll be our success. That's 0.3. So what would be our failure? 0.7. 0.7. Now let's talk about the different allowable values for X. What in this case, let's say X is hitting the target. So what are the allowable values that X would have? X could be what? It could be a 0, it could be a 1, a 2, a 3, a 4, a 5, a 6, or a 7. So this archer could hit the target 0 times, 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, or 7 times. We don't know what's going to result, but they're asking us here to get the probability that the target is hit at least how many times? So probability of at least 2 is going to be equal to probability of 2 plus a probability of 3 plus a probability of 4 plus a probability of 5 plus a probability of 6 plus a probability of 7. Now, if you're not clever, you go ahead and do it the problem that way. But we know you guys are clever. We know, I hope, that you realize that if you take probability of 1 plus a probability of 2, probability of 0 plus a probability of 1 plus probability of 2 plus a probability of 3 plus a probability of 4 plus a probability of 5 plus a probability of 6 plus a probability of 7, what does it have to equal to? 1, because the sum of the probabilities has to be equal to 1, right? So therefore, if you take 1, I'll do this, the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of 6 plus the probability of 7 equals 1 minus the probability of 0 minus the probability of 1. So in other words, you just compute 0 and 1 and subtract it from 1, and you're going to get the probability of at least 2 must therefore equal to 1 minus the probability of 0 minus the probability of 1. So just compute those two. So does that make sense? Yes. Okay, so so do you agree that n is 6? Do you agree that p is 0.3 and q is 0.7? What's 1 minus 0.3?
Oh, okay.
Q is
Yeah,
just,
so Q is the.
is it fail?
Is
Yeah,
the probability that he's not getting started.
correct.
Okay.
Now, the possible result, the possible values x could be is 0 through 7. You see that? You understand that part? Okay, so how many ways could you hit the target 0 times? Greater than or equal to 2, at least 2. Okay, so here's our problem. Guys, don't overthink this. So first, let me clarify. Your x values, could you, out of 7 times that you tried, and the problem says, oh, so let me erase that. Okay, so 6 times. So then it stops here at, there, I'll fix it. So the allowable x values are up to 6, right? Let me go ahead and fix this here. And fix this. There, now it's fixed. Okay, so you can get, if you try 6 times, you could hit it 0 times, hit it once out of 6 times, or twice out of 6 times, or 3 out of 6 times, or 4 out of 6 times, or 5 out of 6 times, or 6 or 7, or 6, that's it. Because we tried 6 times. Agreed? So now they asked us to find the probability. They asked us to find the probability of at least twice. Meaning that you hit it 2 or 3 or 4 or 5 or 6 times. And so now you have to see that I can go ahead and compute 2, 3, 4, 5, and 6. But that's like kind of dumb. Because if I realize that if I add it up from 0 to 6, it has to equal to 1. If I take 1 and subtract just 0 and 1, I end up with what's left over, which is what I want. Does that make sense? There, that's it. So I guess you could call this the rule of complements, right?
So the final answer would be.
Well, the final answer would be whatever that computes it. So like you have to now, unfortunately, I mean, I guess, right, as far as I'm concerned, this is right, but of course we want some numbers, right? So this is going to be 1 minus, and well, over here, p of 0, I guess we can compute over here, p of 0 is equal to 60 0.30 to the 0, 0.70 to the 6, and P1 is 61.30 to the first times 0.70 to the fifth, whatever that comes out to, right?
And you have to write like 0.7, 0.4.
Say again?
You have to write the 0 after the 0.3. It gives you 0.39, 0.30. Right? Yeah.
I'm not sure what you're saying.
Oh, like can he just write like 0.3 instead of 0.30? Same thing. Yep. Okay.
Yes, you can. It's just, yes. Yes, it's the same thing. So if you computed this, I'll just go ahead and compute it here on my thingy here. So if I computed this, we have 6 zeros 1, so it's 0.70 raised to the 6 is just the first one. I'm gonna keep this in memory. So this is approximately they want 4 decimal places, I'm assuming. And then the other one is 6.1, which is 6 times 0.30 times 0.70 raised to the fifth. And that's 0.3025. 0.3025. So now I'm going to go ahead and subtract 0.1176 minus 0.3025. So we got, I'm going to keep in memory here. So that way it should work out the same way. So it's 0.5798. So that's 1 minus 0.1176 minus 0.3025. Now, when I do it here on my calculator, what answer does the book give? Because when I don't round, it gives me a different answer after I round. Because the best thing to do is to work off your unrounded numbers and then round at the end. That's the best thing to do. Like the best way to work this is you actually, like if you do this math here, you don't get that answer. If you do this math here, you actually get 0.5799. Now it's right, but it's like, okay, you worked off two rounded numbers. But if you kept it in memory in your calculator, you use the unrounded numbers first, and at the end you round. Does that make sense?
Yeah, but I have a question.
Yeah.
Your calculator, you can't have it memorized. So how?
You write it down then.
Write the whole,
It's not that hard.
it's not really funny, like,
Now, it didn't matter here because they rounded to 3 decimal places. Either way, it's gonna work out. But just throwing that out there, because I get, if I do this here, it gives me 0.5799. But if I use the actual numbers that the calculator was displaying and then round, then it comes out different.
It just looks scary when I had no.
So like if you use this number, it's whatever. Okay. So was that question that difficult?
No, you didn't know it's still by yourself.
Okay, you want to do the next one on your own?
Yeah.
Let's do that. Let me go ahead and pause the recording. No, because that will waste a lot of memory. You guys were supposed to work on it.
Are you gonna re-explain it for the recording?
Yes. Yes, I'm gonna explain it. All right, guys. So let me go ahead and drag this to the right. Doesn't drag. Okay, whatever. All right, so look at A. It says there, Joseph and 4 friends each have an independent probability of 0.45 of winning a prize. Find the probability that A, exactly 2 of the 5 friends win the prize. So let's go ahead and do that. So part A here, it's fairly easy to do. It's just N is 5. P is 0.45. Obviously, 1 minus P or Q is 0.55. And then X equals to 2. So the probability that exactly 2 win must be equal to 5C2, 0.45 to the second, times 0.55 to the third. And so 5C2 gives you 10 times 0.45 to the second times 0.55 to the third. So let's go ahead and do that. That's 10 times 0.45 to the second times 0.55 to the third. And so we have 0.3369. So I'll just go ahead and say approximately 0.337. Now, part B was the interesting question and one which we took some time discussing and trying to figure out because we didn't know where to go. So it says, find the probability that Joseph and only one friend win a prize. So first thing you guys were saying, well, that means the same thing as A, and it's not. It kind of does, but it doesn't. What you have to realize. So it says Joseph only one friend wins. So you got to realize that, you know, let's say you have Joseph with friend 1 and friend 2 and friend 3 and friend 4. What I want you to realize here is that either Joseph wins or friend 1 wins, or Joseph wins and friend 2 wins, or Joseph wins and friend 3 wins, or Joseph wins and friend 4 wins. Or maybe friend 1 wins and friend 2 wins, or friend 1 wins and friend 3 wins, or friend 1 wins with friend 4. Or maybe friend 2 wins with friend 3, or friend 2 wins with friend 4, or friend 3 wins with friend 4. And if you count these, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what 5C2 does for you. It takes care of 10. But only 4 of these ways are exactly Joseph and the friends. So obviously there's only one way. The way you would do this is you would think there's only one way for Joseph to win, right? And there's 4 ways that Joseph can be paired up with his friends, right? So it's 1 times 4. There's 1 times 4 ways. That's a little hard to think about. So in essence, what you got is you have 4 times 0.45 to the second, right? 0.55 to the third instead of 10. And that comes out to 0.135 approximately. That's it. That was that question. But the interesting part of this question is the discussion of the 5C2 and what it means. That's what this formula does for you automatically. So you don't have to spend your time figuring out how many different combinations of the results we have. Okay. Let me go ahead and pick one more question that we'll do in class.
We'll start at 11.
All right, just quickly so everybody understands or tries to understand. So we have a bag that contains 2 biased coins. Coin A shows heads with a probability of 0.6, and coin B shows heads with a probability of 0.25. A coin is chosen at random from the bag and tossed 3 times. So here's what you got to consider: that there are the part of picking the coin between A and B. That's important because you have one set of probabilities that can occur with coin A and one that can occur for point B. Once you figure that, then you go ahead and figure out the probabilities with this one and probabilities with this one. Well, guess what? Those will happen half the times because the probability to pick a coin at random from a bag when you have 2 of them is half. So you got to remember that. So what you have here is you have coin A and you have coin B. Now, when you read the rest of the question, it says coin A shows heads with probability of 0.6. So P here is 0.6. Q is 0.4. All right. You're welcome. And for coin B, P is 0.25 and Q is 0.75. Now we're tossing the coin 3 times. So N is 3. N is 3. And it says there, A, find the probability that the 3 tosses of the coin show heads, 2 heads and 1 tail. Since heads is the success, X is equal to 2 in both cases. So you're going to go ahead and go, this is going to be 3, 2, 0.6 to the second, 0.4 to the first, and this is 3, 2, 0.25 to the second, 0.75 to the first. And now you get those 2 numbers, you add them, and you get the probability of those two. But guess what? What you got to consider is that these events are occurring where A and the event. So in reality, if you look at this part up here as part of your tree diagram, because it could have been A and X equals to 1, or A and X equals to 0, or maybe A X equals to 3, and it would have been repeated over here as well. But guess what? The probability of A and X equals to 2 plus a probability of B and X equals to 2, since they're both independent events, forces you to multiply half times 3, 2, 0.6 to the second, 0.4 to the first, plus half times 3 to the second, 3C2, 0.25, and I put the division again. 0.75 to the first. And then when you do that math, it gives you whatever answer you're supposed to get. It would be correct. 0.268, I think it was. And I think that's it. So I'll wait because what was it there on a calculator in memory? For that one, I think it was 0.268. 0.286. Was that one? Yeah. Is that the one I did or you did?
No, that was what we did.
Okay,
Oh,
that's,
no, that's one you did, yeah.
that's what I did?
Yeah.
0.286. So the answer comes out to,
So that was A or B?
this is part A.
Yeah. I'm gonna do that one.
Okay, so guys, try to be on your own. I'll post this online. I'll also post some homework for you. Be ready for a test next class.